this is the 11th numerical. Here they have given you one concave lens. Its focal length is also given. And they are giving you the information about the position of the image. The image is formed at 10 centimeter distance from the concave lens. Now they are asking you that if the image is formed at 10 centimeter, then at what place the object must have been placed. So you have to calculate object distance. Okay, and you have to draw the ray diagram also. So whenever these kind of numericals are given, first of all, just write down what kind of lens or mirror they are giving you. So here they have given you concave lens, and we know that it is a diverging lens. Now we'll write all the given information. So see, they have given you focal length. So f is equals to 15 centimeter. Why I have written here minus? If you see the sign convention of the concave lens, then the focus is formed on the same side of the object. Okay, you can check it from the ray diagrams. So the focus is formed on the same side of the object, and hence the focal length is going to be negative. Here the image is also formed on the same side. Why the image is also formed on the same side? We have again seen the ray diagrams of the concave lens, and there the images were always formed on the same side of the object, and therefore you have to remember that whenever the object and image are formed on the same side, then the image distance is going to be negative only, because see, we measure all the distances as positive along the direction of the incident ray. So if this is the object, this is the direction of light. Okay, and if this is focus, then I'll be measuring the focal length in this direction. So incident light and focal length are in opposite direction, so focal length will be negative. Okay, now here what is happening? The object and the image are always on same side for the concave lens. So image also will be somewhere here only, on this side only. So see, this is the direction of incident light, and I will be measuring the image distance along this direction. So both the directions are opposite to each other, and therefore the image distance also will always be negative. Okay, this whole topic we have discussed earlier. Still any one of you have any doubts, then you can message me. Then whenever we'll have live class, we'll discuss that. Okay, so now just see here. So focal length and image distances were given, and they are asking you to calculate the object distance. So till here we have written. So now what is the relation between f, v and u? So that is the lens formula. So we wrote the lens formula. I want object distance, so I will make 1 by u subject of equation. Now I'll substitute all the values. You know that you have to substitute all the values along with their signs. So v was minus 10, f was minus 15. This minus and minus will become plus. And now solve this. After solving, you will get u is equals to minus 30. Okay, so as you obtain the answer, then you will understand that the object is also on this side only. So this is the incident light and this is the object distance. Okay, so we have calculated at what distance the object will be placed in front of concave lens. Now they also asked you to draw the ray diagram, so we'll draw the corresponding ray diagram. So first of all, draw the concave lens. Okay, then object distance kitna hai beta? 30 centimeter. Sorry, I forgot here to write the unit. You all mention the unit over here whenever you write the notes. Okay, so object is placed at 30 centimeter. Again, you need not take perfect 30 सेंटीमीटर डिस्टेंस. ठीक है, वो आपको करने की ज़रूरत नहीं है. आप रैंडमली कुछ डिस्टेंस ले लो एंड यू हैव टू मेंशन हियर 30 सेंटीमीटर. ओके, फोकल लेंथ कितनी है? 15 सेंटीमीटर है. सो आप ये 30 है अगर, तो उसका हाफ जहाँ पर होगा वहाँ पर फोकस बना देंगे. तो इस तरीके से यू हैव प्लेस्ड the concave lens, you have placed the object, you have placed the focus. Now I need to draw the ray diagram. So for that I will be drawing two rays. So one ray I am drawing which is parallel to the principal axis. This ray will get diverged. But I know I have to elongate it in the backward direction, and then it will be passing through focus. So here you can see that this ray has been elongated in the backward direction and it intersects the principal axis at focus. तो वो first वाला ray आपने draw कर लिया. Now to obtain the position of the image, I have to draw another ray. So the another ray which I have drawn is passing through optical center. So we know that the refracted ray will move in forward direction, okay, without bending. And wherever the two refracted rays intersect, head of the image will be placed there. So here you can see at this point, both the refracted rays are meeting. At that place, you are going to place the head of the image. So that is A dash. The tail of the image will be lying on the principal axis. So that is B dash. So now you can draw the image A dash, B dash also, and then mention all the distances. Okay, so that's all for the 11th numerical.